Today we were going to discuss chapter 7 in laws of indices. So we have to remember these 5 general rules. The first one, before that, let's recall what do you mean by indices. If you say you have 2 to the power of 3, it means you multiply 2 3 times. So this will be 2 times 2 times 2 will give you 8. So this is our exponent. So this and 3 power 2, this means 3 multiplied by 3. So this is 9. Naming this one, if you say 5 to the power of 2, this 5, this is what you call as your base. And this 2 is the power or the index or exponent. Index or exponent. So this could be power, this could be index, exponent. This one is what you call your base. So let's have the laws of indices. So the first one, this is only if the operation is multiplication, you have the same base, a and a. So that means you will just add the powers. If the operation is division, this one, this is division, use same base, you subtract the powers, m minus n. Any number raised to the power of 0 will give you 1. Number 4, law number 4, a to the power of m, power m, raised to another power, you multiply the powers, m times n. And then, if the power is negative, how to make it positive? You simply bring it down. So 1 over a power n. So that means if the power is negative down, how to make this positive? You just bring it up, a to the power of n. So let's apply the following rules. Let's have example number 1 in exercise 7.1 of your teaching notes. So the first one, a 5 power 7 times 5 power 13. It means they have the same base, so we'll just simply add the powers. 7 plus 13 will give you 5 power 20. For letter B, 9 power 8 times 9 power 5. The operation is multiplication, so we add the powers. 9 power 30. Letter C, all are of base 11, so we'll just add the powers. 2 plus 3 plus 4 will give you 11 power 5, 11 power 9. So this is rule number 1. So let's continue. Let's have example number 2. So we have here, the operation is division for all. And then same basis, 15, 15, 4, 4, 5, 5. So what to do here? We'll just subtract the power. So here, 3 minus 2, which is 1. We don't need to write 1. Letter B, same base 4. 18 minus 9 will give you power 9. Letter C, 20 minus 19, it's 5 power 1. So we don't need to write 1. It is already considered that the power is 1. Let's have more examples. Let's have number 3. Number 3a, same base a, so that means 7 plus 3, 10. For B, same base a, 4 plus 5, 9. For C, B, 11 plus 10, and this is power 1, so we'll give you 22. 11 plus 10 plus power 1 will be 22. Okay, let's continue with A. So this will be same base x, 7 plus 8 is 15. Y, same base y, so y power 4 plus 8 plus 9. 4 plus 8 plus 9 will give you y power 7, 21. Okay. So let's answer this question number 5. Explain why the laws of indices cannot be used to simplify 19 to the power of 8 times 17 to the power of 8. Now, we cannot apply the laws of indices here. It's because the bases are different. So here, different bases, so we cannot simplify. So remember, we can only simplify if they have the same base. So we cannot do that here because this is 19 and this is 17, different bases. Okay, let's continue with example number 6. Now here, you have a power raised to a power. The rule says if it is a power raised to a power, you multiply the powers. So this will be 7. 3 times 2 will give you power 6. For letter B, 2 times 8, it's 4 power 16. For letter C, 7, 9 times 2, it's 7 power 18. Okay. So here, question number 7. So this will be 1. 3 times 8. 3 times 8 is 1 over 5 to the power of 24. Or, if you want to write this one above, you can say applying the rules for a negative exponent. So this will give you 5 to the power of minus 24. So either you can write it like this or this, the same meaning. Okay, let's have example number 8. How are we gonna simplify this? So this means this multiply times this. And remember rule number 1, if we have that, we can simplify if they have the same base. So x, and there is an x here. So that means we will simplify all x together by adding the powers. And then all y's together. So this will be x power 5, y power 5. Now remember, these are different bases, so we cannot simplify this even more. So this will be your final answer. Now for B. So again, there is same base A, same base B, and same base C. So we'll just add the power. So 2 plus 1, B 1 plus 2, C 2 plus 1. So therefore, this will be A to the power of B, B to the power of 3, C to the power of 3. Okay, let's continue. Let's have example number 9. Remove the brackets and then we will gonna simplify this. Now, remember, the rule says if you have a power raised to another power, it means you multiply the power. So m times n, it will become a to the power of mn. So let's apply that one to example. Okay, let's continue. Let's start with 9 letter A. So this is x squared y 4 raised to the power of 5. So since there is another power here, so that means each you multiply the power with that exponent. So this will be 2 times 5, 10. 4 times 5, 20. Let's continue with letter B. So for letter B, so this will be 9 power 2, x3 power 2. This will be, the exponent is 1. So this will give you 9 squared. X 3 times 2 is 6. And 9 squared, remember, it's 9 times 9. So 9 times 9, it's 81. X power 6. Okay, let's have letter C. For letter C, minus 3 power 3, x power 3. Okay, and then this will be power 1, so we'll just multiply, no? Minus 3, 1 times 3, it's power 3. 1 times 3x power 3. And minus 3, it means minus 3 times minus 3 times minus 3. This is minus 27x to the power of 3. Okay. Now, let's have for question number. Okay, let's continue by answering question number 10. So, question number 10a, z2 power 3 all over z power 3. Power raised to power, that means you multiply the powers, right? So, z6 over z3. And since this is division, we will subtract the power. 6 minus 3 will give you 3. Now, let's go to question letter B example. Y power 3 raised to 2, y power 2 raised to 2. Power to power, meaning you multiply. 3 times 2, 6. 2 times 2, 4. And then division, so that means you subtract. 6 minus 4 will be 2. So that's why y power 2. Now for letter C question, x3 power 2, x2 power 3. So this will be multiply 6 and 6. So it is division. So this will be 6 minus 6, which is x to the power of 0. And remember the rule, any number raised to 0. Any number raised to 0, it's 1. So that's why this is 1. So, and remember the rule, any number raised to 0 will give you 1. That's why x to the power of 0 is just 1. Or here, remember that if you, for example, 5 divided 5 is 1. So here, this is same. So that's why the answer is 1. So this is applying all the law of indices. So let's continue with if the power is negative. So let's have more examples now. If the power is negative. So let's have exercise 7.2. The instruction is write each of the following using only a positive power. So we have to rewrite this to make these powers from this negative, we will change it into a positive power. So for letter A, so the rule is if the power is negative, you will bring it down to make it positive. Or if it is down, how to make it positive? Bring it up. Okay. So let's start with example letter A. So how to make it positive? So we'll just write it down. So 1 over x to the power of 4. Letter B. Now to make this positive, we'll just put it up. Letter C. Down, and then voila, it will be positive. Letter D, again put it down and that makes it positive. Letter E, so it is negative down, so put it up, but 1 you don't need to write. F, so down. G, again down and positive. H, again down. So I will be positive and then you put it up. So this is how you apply the rules of or the laws of indices. So just remember the rules of indices. So remember the rules of indices. The operation is multiplication, same base. You add the powers. If it's division, same base. subtract the powers. Any number raised to 0 will always give you 1, and power raised to a power, you multiply m times n, and if it's negative, you put it down to be positive, and if it's negative down, you put it up to make it positive. So that's the end of this chapter, laws of indices.